ladies and gentlemen. Welcome on board to this flightacademy.info class.
50, 40, 30, 20, retard, retard, retard.
Today we are going to explain what density altitude is. Special altitude corrected by temperature. Why is so important density altitude? Because it's directly proportional of the density, and the density is what it makes our engine, for example, working better, or our flight controls. It is important to study this because if it's helping us, we can use, for example, less runway or climb farther or better, or even fly much more miles. But before entering in detail with this concept, I would like to show you the main reason of having this concept. The main reason are these tables around here. As you could observe here, you have outside air temperature, and here you have pressure altitude. With the result of this is the density altitude. In this chart, we are going to calculate the takeoff distance with 0 flaps, full throttle before brake release, paved, level, and the runway is dry. An importance of the density, and I think with this example you will see it much better, is imagine somebody swimming. It's not the same swimming in the water, in the swimming pool, that in the sea or in a swimming pool full of oil. Why? Have you ever wondered why? Because the movement forwards depends on the quantity of mass of fluid that we are moving backwards. It's the third law of Newton. So that's why if we have higher density, so we can move more molecules downwards, we will go farther. This is how it's the big concept of how a reciprocating engine works. In fact, all aviation engines, the main principle is the third law of Newton, so more or less this is the explanation of how it works. What we do to understand better this concept, we take the international standard atmosphere, and we as engineers, we are performing some calculations. For example, imagine that we are at 5,000 feet, okay? We are at 5,000 feet. We are getting a density of 0.8617. Okay, at 10,000 feet, we are getting a density of 0.785. So we, as engineers, we calculate the runway distance, for example, at 5,000 feet. And it will be, I invented, 1 kilometer. Imagine that now our runway is at 10,000 feet. How much runway would we use? So maybe 1.3 kilometers because of the density. At higher level, we have less density, as we can see. Okay, what's the problem? That these values of density are related to the international standard atmosphere, but normally we are not in the condition of the international standard atmosphere. So it could happen that someday we are taking off from at sea level, for example, but it's very hot, or we have a lot of humidity, or a sum up of factors that could make that our engine behavior is as if it was higher. For example, imagine we are taking off at 5,000, we get 1 kilometers the accelerated stop distance, but another day, changing its condition, this runway that we are going to need is 1.3. Okay? How do we manage it? We calculate this performance, this aircraft performance in each altitude. So then we only have to move the real situation to the table that we have already calculated. This is the situation. The most important thing is to know what is helping you and what is against you. And what is going to help you? Everything that makes our density be higher. As we said before, higher density means that our molecules of fluid are bigger. Remember that the density is the mass divided by volume. And as you see, the higher is the density, you can see here and here, the higher the density is, the smaller the density altitude is. That's why we are always interested on doing this. That the altitude, we are always interested that the density altitude is always low, as lower as possible. Which factors modify our density? The factors that modify our density are the factors that are in this formula. Pressure is equal to density, this is a constant called Boltzmann constant, and temperature. Okay, so now we are going to see each case separately, how it reacts, the density altitude, when we are modifying one of these parameters. Imagine that the pressure is increasing, okay? And the temperature is constant. Temperature is constant. You know? What is going to happen here, if you see this formula, is this one is rising. This one we don't know. This one is a constant and the other is a constant. So to maintain the equal, the density must rise. In this situation, the density must rise. And if the density is rising, the density altitude is dropping, which is good. You know? Another concept I'm going to raise. Imagine now that the pressure remains constant. The temperature is increasing. You know, if we are again watch our formula, this one is constant, this one we don't know, this is a constant, and this is going up. So to maintain the equal, the density must drop. And as the density is dropping, the density altitude is increasing. This is so bad. Now, for example, in summer, our plane is not working as better as in winter, for example. Imagine the high. The higher we are flying, the less density we have. And as we know, when we have less density, our density altitude will be increased, and this is not good for our engine. So your next question could be, why are the airplanes flying so high? And the answer of this is that the speed that they are getting in that height is much bigger. And I will show you in a picture that I did while flying that we have a little bit more of 260 knots, and our true airspeed, which is on the instrument on the left hand side, is 447. So imagine, that makes a big difference. Humidity will be the next one. The humidity is just water vapor in the air. So imagine that we take some air, very humid, and some air, very dry. Okay? If it's humid, we have here, and if it's dry, if we check the periodic table, we can see that our hydrogen weighs 1, and the oxygen weighs 16. So, in the situation number 1, we have 2 hydrogen, which means 2, plus 1 oxygen, 16. The weight of this is 18. But on 2 we have 2 hydrogen, 2 and 16, and it's double, which is 32 plus 2, 34. The number 2 is breathing weights. Number 2 weighs more. That makes that the density here is bigger than here. So, if the density when it's humid is lower, the density altitude is higher, which means that we don't like it, that is working a little bit worse. I hope this small explanation clarifies some of your doubts. Anyway, you can write me and I will answer as fast as possible. Thank you and have a nice flight.